Hey Nathan, so I hope you understood and liked the explanation in the previous one. So in this one, I'm explaining the network economies, the one of the other photos that you had sent on your tweet. Um, okay, so for this, it's quite simple, but a little complex than the last one. There's some assumptions as well on the side of the author, such as this one. So what they're taking is the assumption that the total size of the network is equals to plus NW. So this is an assumption that they are taking, that the total size of the network is equals to network of the strong company and then plus the network of the weak company. Although it wouldn't matter that much, but it's important to understand all the assumptions that are taken in place. Now, the first thing that they are trying to find is the price premium that a strong company can charge than the weaker company. So the price premium is given by the difference between the two prices by the two companies, which is denoted by the strength of their network, the difference of the strength of their network, and delta. Now, this delta is very interesting because this gives me the marginal benefit on adding a new customer, a new joiner. I'm trying to use the same words as given in the book so that you can follow along with the book as well. So essentially what they're saying is how much benefit the whole of the network, the rest of the people get benefited as one new joiner is added to the network, the essentially the basis of network economies. So now, again, why are they multiplying with this? Because the network strength, right, the marginal benefit that each person gets when they get added onto the network, multiplied with the benefit of the network then itself, because the stronger network is stronger company has the better network, so the benefit of the network itself will give me the price advantage, which is the difference between the two prices, right? So that's why we are multiplying both of these. Now, for the profit, again, we're using the same terminologies as the earlier one, which is pi is for profit, and it is given by price that is charged minus the small c. Small c is the variable cost into the q of the number of quantities that are produced in that time period. Now, what will govern S is what will govern the margin of S. Okay, so what will govern the margin of S? The condition that they're saying, margin of S such that the price is set so as to get the profit of the weak company as zero. So what governs S is margin. Okay, what will govern the strong company's margin when the price is set, such that the profit of the weak company given is zero. So when we write this as zero, we're essentially writing 0 equals to price minus cost into quantity of the weak company. The quantity will get divided by 0, which will obviously become 0. Therefore, the cost becomes, I'm also mentioning the price of W. So the cost, the variable cost becomes the same as the price for the weak company. So the how much the cost that they're putting for each uh, uh, person is the price that they're charging. So they are essentially breaking even on each of the acquiring the CPF. Now, when we have this relation, we can put it back into here. So we can put PW equals to C here, which gives me the price of the strong company as delta NS minus NW plus C. And this is, remember, this is small c, so variable cost per added customer or joiner, right? Now, when I have this new P, what will be the profit of the strong company? And let's find out the profit of the strong company by using this. So P of S minus C into Q of S, which will give me, and I'll put this values here, delta NS minus NW, and I use the brackets very generously so that you do not get confused between what is get managed where. When I open the first bracket, this will get cancelled by this, and that's why the use of brackets is extremely important here. And so the final value that we get, which is the profit, is delta into QS into NS minus NW. Right? This is my final profit for the stronger company. Once I have the final profit, now I can find the margin. And remember, the margin from the previous calculations that we've also done is essentially the profit upon the revenue. So margin is equals to pi of S, which is the profit of S, upon the revenue of S. And revenue is essentially P into Q of S, right? Revenue is essentially the price that they are charging and the quantity of units that they're producing in a unit period of time. So profit, I'll write it down as delta QS NS minus NW upon, now price into the thing, so I'll be using the same price as this, so delta, so you can see delta, and because I have to multiply with Q, so I'll multiply it with Q as well, or yeah, let me first write down the price itself, plus C and into QS. Now once I have QS, because it's both in the numerator and the denominator, I will be cancelling it out. So the value I get is this much. Now you can put this, just to understand it easily, I will put this whole thing as X, okay, just for the sake of simplicity. So when I put it as X, I get X upon X plus 1, X plus C, sorry, X plus C, right? They are the same. Once I do this, I can basically X plus C, X minus C. I can do this because essentially the sum is 0. And so I can basically add 0 in the numerator. And in the denominator, we already have this. And now we can separate it out, which will give us 1, because X plus C upon X plus C will be 1, minus C upon X plus C. Right? I hope you are able to follow this. So now we have this new configuration of the equation, which is 1 minus C upon X plus C. And now we will put back the value of X, which is equals to 1 minus C upon delta NS minus NW plus C. And we will take C common. We will take C common. And 1 will be left there. And this will get cancelled. And we will have the final the surplus leader margin equation over here, right? And the equation is simply 1 upon 1. I'll change in this only because I don't want to delete or remove things again from below, right? So I get the final thing, and this is my margin, which is what I'm checking at this point, right? I hope you're able to follow the equations. Now, in order to understand the conclusions are also fairly easy to understand. First, the competitive position, which is NS minus NW, which is the worth of the network itself, right? The worth of the network itself. So this is the absolute difference in the installed base. So how important or how good the base is. That is the absolute difference. That basically we are checking how the margin of S is dependent on these. So this value, the more this value is, the better it will be, right? Next is industry economics, and this is given by delta by C, which is where the value increases with each additional user per dollar variable cost. So as the dollar variable cost increases, the value of the network or the industry economics also change with each dollar that is invested or into it, right? Finally, you can see if NS is equal to NW, okay, if NS is equal to, so the network worth of the network S by the stronger company and the weaker company, if they are the same, then this will become zero. If this becomes zero, this will become non-existent, and essentially, because this is in the denominator, don't forget. So if this becomes zero, this whole thing becomes this into this will become zero, this will become one, and once it becomes one, 1 minus 1 will become zero, so the margin will also become zero. Okay, understand again. If NS is equal to NW, that means both the networks are the same. This into delta by C will become zero. Once this becomes zero, I will only be left with 1 upon 1. 1 upon 1 minus 1 will be zero, and so my margins will be zero, right? So there will be no leader as such. But if NS is greater than NW, if NS is greater or extremely better than NW, then this will be a higher number. So suppose if the total sum, that means that what we took as N is equals to NS plus NW, if we take the sum as say 100, or let's take 10 just to simplify it for ourselves. If we take it as 10, then N minus NW, that means uh, N is bigger than NW, so we can take NS as 1, NS as 9, right? If we take this as 9, NW is only left with 1, which means this becomes 8. 8 into the industry economics plus 1, plus 1. Now in the denominator, we get a bigger value, right? The bigger the value we get here, the bigger the value we get here, the smaller the overall value of this ratio will be. Okay, so if this gets bigger, the denominator, the whole thing gets smaller, right? Because 1 upon anything, if it's like this, if this gets bigger, the whole ratio becomes smaller. Once it becomes smaller, 1 minus that ratio is larger. And that is exactly what we want. We want the margin to be higher. So NS becomes greater, and so the smaller this is, the more value of 1. So we might get the value as 0.999, whatever the case may be, and that means we are getting almost 100% of the margin, right? And obviously the case here is that the delta is greater than 0. If this is not greater than 0, then this will all go for a toss and it will become the opposite, right? If this is 0, then essentially this is 0. The whole margin will be 0. If this is become negative, if this becomes negative, negative minus positive will become negative, which will become addition, and that then the whole thing will become more than 1, right? So that is also possible, but we want it to be ideal case for us, and that is only possible when this is more than 1, more than 0, right? Positive. So I hope you understood the equations. They are not very difficult, but a little complex written there. So yeah, I hope you enjoyed this, and I hope this added value to understand both the equations for you. Bye. See you.